All right, I took a little break, and as I was on my break, just sitting there letting my brain defrag a little bit, I thought, you know what? I wonder if the issue is calling string token twice. I wonder if the issue is being in the midst of a string token process, going to this function and calling string token again, because there's clearly some under the hood stuff going on with how string token works. I mean, the fact that you can pass in null and then the same delimiter, and it will know, okay, hey, we're continuing to process the same string that we originally started with, but because null is passed in as the first arg instead of a string, we need to go find where we left off with the previous one. That makes sense. There's under the hood stuff happening with string token. Now, there's no sort of identifier or handle or anything for this string token process, which means it's all under the hood attached to just a string token function, which would indicate to me that it's not something that can be called on another string in the midst of that process. That's my guess. I'm sure we can test this by just passing in this. I'm not sure if this actually is a valid call to string token, but right. Literally just calling another. Okay, so that's the issue. So the question is, that was awesome that I just, on a break, my brain was able to like figure out what the issue is. So there's two things to do here. One is just search how do I do string token for two different strings at the same time, or at least like, you know, interleaved. Another thing is to just kind of figure out a solution myself, and one way to do that is instead of calling string token while in the midst of the string token process, is to take all these substrings, throw them in an array, and then process those afterwards, so we're not doing it multiple times. So let's just do that, because that seems easy enough. And the way I'm going to do that is to actually say, we could have a 2D array of substring indices, you know, so we'd have, for example, an array of 0 to 2 is the start and end of the indices, and then, you know, 3 to 4, you know, that sort of thing. So kind of just pairs of indices. That's a way to do it. You know, make a struct for it that has the start and end, make an actual array of strings. That might be the best way to do it. Let's just make an array of strings. Substrings. I don't know how many there's going to be, but let's just try doing that. Well, the problem is, well, that doesn't really help us, because if we're able to, no, that works. That's fine, because so we can get rid of all these now, I think. So we'll want to parse range later. We shouldn't need to print the hardcore anymore, or copy that, at least not in that way. So what we'll want to do instead, so for each string, always curious how to do the pointer stuff with this though. Because with substrings is an array. Oh, we don't want an array. That's like triple pointer. An array of pointers. Okay, there we go. We still need to allocate that, right? So we should be able to say substrings index calc. How do we get the length? We'd say a pointer. And then we'd so we allocate memory for a new string, and then we copy in substring index. So we'd copy into that question mark. Copy in pointer, maybe. I don't know if that even will compile. Substrings. So I'm always, it's kind of a I don't know if design's the right word, it's a little too fancy of a word, but like the variable name substrings index, does it make sense to call it, you know, essentially array name index or array element index? And what I mean is, this would be an element of substrings would be called a substring. So do you call it substring index? Or do you base on the array name and call it substrings index? It's an index into substrings, but it's an index of a substring. Maybe it makes sense to, I mean, either way, kind of, it's like a 50-60 or a 54, 60-40 kind of situation. Okay, does that compile though? No, because I'm still using substrings index. Okay. Can I printf substrings? Okay, so we did properly do all of that, and again, probably not good practice to like use calc for this, but I'm not really sure how else to do it, right? That's the god. Because this is a weird question to Google. Say I am reading some input, and I'm parsing substrings from the input, from a file, for example, and I want to then store these substrings in an array of strings in C. I'm going right now I'm calcing strings to store the substrings. Is that the best practice for this sort of deal? Interesting. Stern dupe. Pointer normal returns a pointer to a null terminated string byte string. Oh, it's done dynamically using malloc, and hence it can be freed using free. So you shouldn't free it, but it's kind of the same thing then, huh? So instead of calcing, I can just duplicate. Well, it'd be start and end. It's different because I don't have a string dump versus stirred up. Takes a string. String dump takes a string and a size. Oh, and just means that takes a size as well. pointer. Does that work the same? Did I remove the print statement? Right, because that works the same. I mean, it's really the same difference. Okay. Cool. So now we have our substrings, and then we can go through our substrings so for each substring, we then want to parse it and say, because then we'd want our ranges up here. So all of these are what we actually need now, right? Parse substrings. Let's say extract substrings. Okay. Parse substrings. Because now we're parsing data from substrings. So we're starting our end. Okay, and we don't really care about our strings, so we can just pass those in. So we can just parse range, pass in substrings I, and pass in our start and our end. I'd be able to replace these honestly with just a struct member. I'd say our ranges for our current one. Cool. Alright, so for each one we're doing that. It seems to kind of make, and then we also want to increase. Okay, cool. So that works, great. Now let's just say instead of doing it this way, let's actually make a struct which is like what, a product ID range. Should be our substring index, that's how many we have. Product ID ranges, and then instead of this, is there a way to initialize array of structs with certain member values? Well, I guess we could just do it this way. Prs I dot start well, there should be a way. Initialize all elements of array to value C. So if we do this, this will initialize all to 0. Okay, I'm curious about this. So if we have destruct so if I was to make just a single thing, I could make this have a start 1 and 2. Sure. Makes sense. And if I was to do an array of values, I could do this. An array size of our. Oh, sure. Let's just do it this way. Sure, makes sense. Oh, actually not really. This initialize all elements to 0. Well, sure, if it's 0 is what you want, but can you not do a single value? Unless that value is 0, there's no easy way. Okay, you can't do it. Okay, well that answers that question. Because I was curious if you could do something like product ID range equals something like this, where you'd say like -1 or something. So like all the members of that, all the members of all the elements of PIR of PIRS, the product ID range array would be -1. But that's okay. We'll just do it this way. And then, so we don't need, so that was before this was necessary because we had, yeah, we don't need that because we had these kind of temp values here, and those would be used as kind of placeholders and kind of temporary buckets, and then you transfer them out of them into the ranges array. We don't need all that though. Product range pointers at end. So you need to use, oh sure. There we go. Cool. Awesome. So all of that work, about an hour and a half, and we now can kind of parse some of the input. Right? I'm not sure why I ended up doing this in Sandbox, but we did. Right, so now we have this function that takes a string, which is our input. Parse substrings into an array of PIRs, product ID ranges, and then return that, I guess. You can only return an array though. You can malloc it though. It's the number of bytes. So we'd want times size of product ID range, which that would be the size of, what is that, 16? Eight. Oh, because the size of an int is 4. Okay, sure. Dope. So we get all of that. That's not gonna work. That's not a pointer. Cool, cool, cool. It's crazy how effective it is to just take a break and come back. Crazy. Awesome. And honestly, I don't need any of this code. I can just delete this and just move sandbox. Cool. Dope. Dope, dope. So we can get rid of some of these output stuff that we don't really need, because that's just for parsing the input, for debugging parsing the input, really. That's fine though. Don't need it. Just clean up the output a little bit. Cool. So now we have that, and now we can actually parse database string, really is what it is. Okay. Cool, 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 cool. Cool. So now that we have that, we can actually work on the problem now. So then for each number. Oh, that's still the hard part. That's I swear that's a LeetCode problem, figuring out the double things. I imagine you have a sorted. I feel like recursion has to be used though, right? Like it's one thing to be like, all right, do we have the same character in a row? That's fine. But when it's a sequence of characters, right? When it's, do they have an example of one? Right. For example, 4 4. The overall repetition is 4. Well, the thing is, if you have a repetition, is it only based on doubles? Because if it's that, then really what you're saying is the first half of the string is the same as the second half. If it's only doubles. Repeated twice. So I'm guessing part 2 might be like, oh, it's actually not about it being repeated twice, it's about repeated any number of times. So like in this case 446, 446 is invalid. But if you were to have 446, 446, 446, that wouldn't be invalid because the halfway point, well in this case, it's not even divisible. It's not even, so you can't divide it by 2. But like for example, 4455 or 4. Let's just do 4 4. What? Like this is invalid, right? Because you have 4 4 5 5 4 4 5 5. Right? You had divided in half. Numbers are the same. Not divided in half, but split it in half. Whereas it's almost saying at this point, if you had something like this, that wouldn't be invalid. I'm guessing part 2, that's going to be the problem. But without that, that's actually a lot easier than I thought it'd be. So PIR is just going to be this. Can I get the length as well? The thing is, yeah. Let's just say PR count equals. I mean, honestly, it makes more sense to do it this way. Come down here. We're not out malloc anything anymore because we're doing that down here. Return the count. Pass in the PIRs. Oh, undeclared. Sure, sure. We need to malloc this af. Well, that's the problem. We don't know how many to do. That's kind of challenging. We don't know how many to do because we need a malloc first. We don't actually know how many. Well, we can count the number of dashes. Get the range count. Pointer is not. So we get the PR account. 11? 11? Oh, sure. If it equals a dash. Great, cool. Great, great, great. So now we have that. Then we can allocate that. We can allocate that base on the count there. Our count. And then we don't need to return anything here. Well, we can. Either way, if you have it.
Well, the problem is we want that number out there. Right?
It's just memory. So we want that number out there, but we don't need to return anything then. So we can it doesn't really matter where we malloc it. I only moved the malloc out here because I wanted to make sure we could get the count in some way, shape, or form. But now we get that there. I think it makes sense. I mean, it doesn't really matter, right? Because again, it's a freaking admin code. It doesn't matter if I'm not freeing memory, you know? It really does not matter. So let's just malloc it in here now. And then that way that should be consistent as well. I assume it is. Set string index. And then return PRs. So then this should be Does that work? I think so.